Today we're diving into the most ferociously bright objects in the entire universe. And no, they're not stars or even whole galaxies. There's something way, way stranger. These incredible cosmic lighthouses we call quasars. So let me ask you something. When you think about the cosmos, what's the single brightest thing you could possibly find? Well, the answer is going to completely challenge your sense of scale.
And here's why. On one hand, you've got an entire galaxy, a sprawling city with hundreds of billions of stars, and on the other, a single quasar. But here's the paradox. That single, tiny point of light can actually outshine its entire home galaxy. Some are so bright they can blaze with the light of 1,000 galaxies combined, all coming from a space no bigger than our solar system. How is that even possible?
All right, so let's get into it. This is a real cosmic puzzle. And the story of how scientists figured this all out, it's like a great detective story.
So the name itself, quasar, is actually a huge clue. It's short for quasi-stellar radio source. You see, when astronomers first spotted them in the 1950s, they just looked like faint little stars. Quasi-stellar literally means star-like. But these stars were also blasting out these ridiculously powerful radio waves. They were cosmic imposters hiding in plain sight.
So how did we finally crack the code? Well, like so many mysteries in astronomy, the answer was hiding in the light itself. It just took one key observation to blow the whole thing wide open.
Okay, so picture this. It's 1963, and an astronomer named Martin Schmidt is studying the light from a quasar called 3C273. He's looking at its spectrum, and it just looks weird. The patterns are all wrong. But then he has this aha moment. He realizes it's the signature of hydrogen, but it's been stretched or redshifted by a truly incredible amount. That was the smoking gun.
And here's why that changed everything. That massive redshift meant these things weren't nearby, not at all. They were billions of light years away, deep in the early universe. Now, for us to be able to see something from that far away, it can't just be bright. It has to be almost impossibly, unimaginably luminous. So the mystery wasn't what are they anymore, it was how are they so powerful? And the answer lies with the most powerful engine in the entire universe. So now, let's zoom in, right to the heart of a quasar, to see what's powering this incredible celestial dynamo. At the center of every single quasar is a supermassive black hole. And I mean supermassive. We're not talking about your garden variety black hole from a collapsed star. No. These are the true monsters of the cosmos, millions or even billions of times more massive than our sun, just lurking in the core of galaxies. Now, a quasar shines when this cosmic monster feeds. As stuff, gas, dust, even entire stars, gets pulled in by that insane gravity, it doesn't just fall straight in. It forms this massive, swirling whirlpool called an accretion disk. The friction in this disk is so extreme that it heats up the material to millions of degrees, converting the raw power of gravity into a blinding torrent of pure light.
But what's really wild is just how efficient this process is. Our sun makes energy through nuclear fusion, right? That process only converts about 0.7% of mass into energy. A quasar's accretion disk, it can convert up to 40% of the mass of whatever's falling in directly into radiation. It is by far the most efficient engine we know of anywhere in the universe. And that incredible efficiency leads to some truly extreme, mind-blowing examples. So let's meet the current champion, a quasar with the catchy name J05294351.
First, its brightness. Try to wrap your head around this number. This one object shines with the light of 500 trillion suns. That's a number that doesn't even feel real.
And what's powering it? A central black hole that is 17 billion times the mass of our sun, a true cosmic monster. Its appetite is just as staggering. To fuel all that light, it's devouring more than an entire sun's worth of material every single day. That makes it the fastest-growing black hole we have ever found. Period.
And finally, the sheer size of it. That glowing, superheated accretion disk, the part that's actually shining, stretches 7 light years across. That's 1.5 times the distance from our sun to its nearest star neighbor. The light source itself is bigger than the gap between stars. Just wow.
But, okay, quasars are more than just cosmic record holders. Let's zoom back out, because their incredible brightness makes them absolutely essential tools for understanding the entire history of the universe.
You see, because they're so bright and so far away, quasars are basically time capsules. Their light has been traveling for billions of years to reach our telescopes, giving us a direct look at the cosmic dawn. They're like cosmic backlights, shining through the invisible gas that floats between galaxies and letting us map out the very structure of the early universe.
And this brings us to our final and maybe most crucial point. Quasars aren't just some distant oddity. They actually represent a fundamental phase in the life of almost every massive galaxy.
We now think that the period when quasars were most common, about 10 billion years ago, was kind of like the universe's stormy adolescence. Galaxies were young, gas was everywhere, and their central black holes were just having an absolute feast.
But it couldn't last forever. There's this amazing process called the quasar feedback loop. The energy blasting out from the quasar gets so powerful, it literally blows its own fuel source away. This starves the black hole, the quasar starts to fade, and in the process, it regulates star formation all through the galaxy. So in its violent brilliance, a quasar actually helps sculpt the very galaxy it lives in. And this is where the story comes right back home. It's now believed that most big galaxies, including our own Milky Way, went through a quasar phase. The dormant supermassive black hole at the center of our galaxy, Sagittarius A star, is very likely the quiet remnant of our galaxy's own brilliant, violent past.
It's a pretty profound idea to really think about. That from the darkest, most gravitationally intense places in the cosmos, the hearts of galaxies, can emerge the absolute brightest beacons in all of creation. Which leaves us with one final tantalizing thought. Our galaxy is set to collide with Andromeda in a few billion years. Could that cosmic merger provide enough fresh fuel to reawaken the sleeping giant at our core? Could it turn the Milky Way, just for a time, into a brilliant quasar once again? A beacon for some other civilization billions of years from now?